So here's video number 2. We made it through 7 concepts, so let's keep on keeping on. Concept number 8. Um, the best way I could title this is kind of what restrictions, blah, 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 does it have? Basically, it's just kind of find out like what range of values work in order to satisfy whatever's happening. It's written with these braces, and usually it's, from here to here will work. So let's say one assignment takes 30 minutes, which is half an hour, or 0.5. One assignment gives 10 extra credit points. So you want some extra credit. You need at least 30 extra credit points, but you can't work on multiple assignments for more than 3 hours. So we have a couple scenarios like, well, what's kind of my range of points that I am kind of satisfied with? Well, I need at least 30. So somewhere between 30, and if I can't work more than 3 hours, that's 6 assignments. And so 6 assignments would give me 60 bonus points. And you would write it. That's my restriction for the number of points. I could also do it for the number of hours. Well, if I need 30, I could do 3 of these assignments, which is an hour and a half, but I can't work more than 3 hours. So I'd have to stop with 3 hours. So like the 30 here is kind of given, the 3 here is kind of given. What about the number of assignments? Well, if I need 30, then I need to do 3 assignments in order to get 30. But because I can't work more than 3 hours, well, I can't do any more than 6 assignments. So it just kind of depends on what they're asking for. You kind of plug in numbers. Just make sure whatever they're asking for, you kind of understand what's happening. Piecewise functions, not going to lie, these are a little bit weird. The easiest way to do it, honestly, is to just plug it into your calculator and kind of, well, here, let me just show you. So let's say I have a piecewise function and saying, oh, I want to do 2x plus 1 from here to here, and I want to do x squared from here to the end. Well, if you graph both of them, you'll kind of see what's happening, and then you just determine, like, okay, well, I know at x equals 1 is where I switch. So I'm going to follow this up until x equals 1. And then at x equals 1, I know it'll jump down here to this other graph and keep going. It's really the best way to kind of do it. Plug one of them in, the first one into y equals, and kind of see where it's supposed to go. And then y2 to like, oh, well, this one, 6 minutes needs to go from this graph to this graph. And so again, it'll tell you, you're doing this for the first 6 minutes, but then something changes, and from 6 minutes to the other, 6 minutes past that, you're doing this particular graph. And so you just have to kind of play with your calculator a little bit and kind of piece things together and figure out, first of all, where the switch happens. Because if it says the switch happens at 6 and, well, all of these are kind of moved over or whatever to where it's like, oh, well, now this has a switch at 5 instead of 6, then that's probably not the right answer. Here's what the parent graphs look like. Linear is y equals x. This is like the mx plus b you've been dealing with. Y equals x. Actually, I probably should put it right on the line, but it's a straight line. Quadratic is this parabola shape where it's y equals x squared. Cubic's like this little curve right here. Square root, we saw earlier in the other video, it kind of just starts at one point and goes that way. And then exponential, this goes up forever, and this starts getting closer and closer to 0. Honestly, it may even look like it does touch. It technically never does, but this is concept number 10, just kind of knowing what your parent graphs look like and what each one of them are called: linear, quadratic, cubic, square root, and exponential. Concept 11 kind of goes back to some more piecewise functions. These graphs, honestly, are a little weird. So when you're going through this, please ask questions and make sure that you get this, because it's not super fun. Piecewise, we kind of learned about, well, we got something happening until it jumps, and then something until it jumps. And so that's what the piecewise ones look like. A many to one graph means actually, and if I kind of go back, hold on a second, it actually means that I can have multiple y values. So like jumping back here where I talked about how 4 could go with a 2 or 4, this would be a many to one type graph. A one-to-one type graph is, well, nothing repeats. Let me go back. Nothing really repeats, kind of like a linear, but you know, I can have x going this way forever and the y goes that way and x goes this, and there's no like crazy curves or whatever. And then we have this step function. And honestly, the step function, if you just kind of look at these points and figure out maybe your slope, your rise over run, maybe it's 1 over 1, maybe it's 1 over 2, or maybe it's 2 over 1. You just kind of rise over run for these. Just make sure you don't do it backwards. It's usually like on this one, this would be like a x right here, or maybe a 2x or something like that. They would put basically a y equals mx plus b graph in here, but it's a little bit different for the step functions. Step functions, they look like staircase. And actually, I'll show you how to put these. Actually, let me show you how to put these in the graph. If you hit the math button and then go over to number, you see this int right here. That's saying I have an interval, and let's say it's, you know, 2x or whatever, and it'll actually graph your little stair step. But you got to be careful because math, go over to number. You got to be careful because they can kind of look the same after a while. So you have to make sure you're really counting like these dots here to kind of see exactly what's happening. But we'll go over this again in another, maybe in this video, maybe another one. But you hit the math button. This actually will pop up like 3 different times. They'll ask about one-to-one graphs. They'll ask about many-to-one graphs. So when you see these, please ask questions. Do a couple more on here. Function versus not a function. Welcome to the vertical line test. You have a graph, one way or the other. Take a vertical line, you go straight across. If you can only ever touch one part of the graph at a time, and you can see like here it's down here, but over here it's up here, and here it's down there. And I know this is a thick line, but here we cross, well, there's multiple crosses or whatever. Even here we cross twice. Anything that does not pass the vertical line test, if you touch more than one spot at a time, it's not a function. If you can only touch exactly one spot on the graph at a time, none of those ones like, oh, you touched that whole line. Well, that's because this is a real thick line. But basically, as long as there's not 2 points directly on top of each other and your vertical line only touches exactly one spot on the graph at a time, then you pass the vertical line test. So that comes up a couple times, actually. Again, graphing these crazy graphs, just put them both in and then use your vertical line test to kind of, well, not necessarily see if it's a function, but like, oh, well, I need it to kind of split right here. So I'm going to follow the red up until here, and I'm going to follow the blue past that. And I know your calculator doesn't do 2 different colors, but hopefully you can kind of see like where it stops. You can even go to the table. And so on x equals 2 or whatever, you can kind of see what they're supposed to look like and have an idea. Again, please ask questions. These graphs can get a little bit weird. We still got quite a few to go. Equation to graph to table, wherever you're at, the graph button's here. From y equals the table button, if you hit second and then graph, you can see the x and y table and match stuff up. And obviously you would type in like 2x plus 1 or whatever, 2x plus 1, and I can look at the graph. And which graph matches that? Well, it's the graph that looks like that. Which table matches that? Well, it's the table that looks like that. Which of these tables matches an equation? Well, you can just plug in the different equations into y equals and then go to the table and see what matches up. So 17, 18, 19, this comes up a few times asking you to go from equation to graph or graph to equation or table to equation. And just play around with y equals in your calculator and definitely ask questions. This is not one you want to just guess on. There's a way to figure it all out. I'm going to stop this video here, a little bit shorter, and we will, we're about halfway through these concepts, so keep on keeping on.